triangle similarity shortcuts. Like triangle congruency, there are shortcuts to showing that two triangles are similar based on the similarity definition. That is, that corresponding angles must be congruent, basically so you have the same shape, the corresponding sides are proportional. So same shape, it doesn't have to be the same size. And so just like with the SSS, SAS, ASA, and AAS, we have similar sorts of things for triangle similarity. And also, as with CPCTC, corresponding parts of congruent triangles are congruent, which we have for triangle congruency. Once triangles have been shown to be similar using certain parts, you know that they're similar in all ways. So here are the shortcuts. So based on the first part of the similarity definition, this is AA for angle-angle. If two corresponding angles are the same, you know the triangles are similar. Obviously, the third one would have to be the same, so that to 180. And then, as I said, with CPCTC, how it relates to that, once the triangles are shown to be similar through AA, now we know that the sides are proportional, even if we didn't know that original. We also have SSS. SSS is based on number 2 of the similarity definition, where K is a scale factor. It's also called sometimes a similarity ratio or a length ratio. The idea is that these sides would be ABC, this is KA, KB, and KC, so that basically every side over here is the same as everyone here multiplied by some constant K, and so the sides are proportional. And then we have SAS, which is a combination of the first, of 1 and 2, the two parts of similarity definition. So we've got a side-angle-side triplet, where the angle has to be the same, and now the sides are proportional by, again, this scale factor. So here's some sample problems you can do with this. Explain why the triangles are similar, write a similarity statement for each pair. And again, the similarity statement, the letters have to be corresponding. Okay, we know that these two angles are vertical, and so these are going to be similar by AA, and we can say triangle AXB is similar to triangle where A goes with R, and X goes with X, and B goes with Q. For number 2, we can say that 20 divided by 15, that is 20 over 15, is equal to 16 over 12, which in turn is equal to 12 over 9. And that is true, so this is similar by SSS, and we can say triangle PXM similar to triangle, let's see, P to X is that middle side, and P is the right angle, so that's going to be WA, and then the last letter would be L. And then the last one, these are curved because they're vertical angles, and so that's going to be SAS, because we know that 8 over 4 is equal to 4 over 2. And so the angle in between works, and also the sides are proportional. And so we can say that triangle PQM similar to triangle PQM BAM. Okay. Over here, we can involve some algebra in this. So we want to find out what X is. We know these two triangles are similar because of AA. And so we can say 5 over 6 equals X over 9. You can set up different proportions that work out the same way. We could have also done, say, 5 over X equals 6 over 9. Main idea is you get something like this. And I reduced it a little bit. I reduced the 6 and the 9 by dividing by 3. You don't have to do that, but I think it makes it a little easier. Cross multiply, divide by 2, X is 7.5. Over here, we know these two are similar by SAS because the angle in between similar, and then also 15 over 10 is the same as 12 over 8. So using the fact that they're similar, I can say X over 15 equals 11 over 12. I get a proportion. I reduce this again, cross multiply, divide by 4. And finally, a couple more. For this one, it's a little harder to see because we've got a triangle on top of a triangle. And so we have triangle here, and we have a big triangle here. So that's really what you have to look for. And so 12 over 12 plus 8, and so that's this piece over the long piece, is equal to 15 over 15 plus 10. Okay? And so basically we end up getting that the triangles are similar. Alright, so now that we know that, we can say 12 over 17 is equal to the whole side, 12 plus 8 over X. So we have to add the 12 plus 8, and we simplify, cross multiply, and we get all the way down to 28 and a third. Same idea over here. 4 over 3 equals 4 plus X over 8. So 4 over 3 equals 4 plus X over 8.